Come with me, let's take a journey. Not to a distant star but to our next-door neighbor in the solar system. A world shrouded in mystery, named after the Roman goddess of love and beauty. But don't let the name fool you. Venus, unimaginable extremes, lessons for Earth. For centuries we looked up at that brilliant point of light, morning star, evening star, and we dreamed. We imagined a lush, tropical paradise, a twin to Earth hidden beneath a blanket of clouds. The truth is far more terrifying and more fascinating. Think about it. Venus is so similar to Earth in size, in mass, in composition. Earth's twin, born from the same whirling cloud. For a time they might have looked alike, two blue marbles orbiting a young star. Earth became a haven for life, oceans, continents, brimming with diversity. Venus became a vision of hell, scorching, crushing, toxic, no life as we know it. The story of Venus is a cautionary tale. It's not just astronomy, it's our planet's possible future, a climate change laboratory on a planetary scale. Imagine the solar system as a grand cosmic dance floor. The sun, our star, sits at the center, a brilliant beacon of energy. Around it, the planets perform a slow, elegant waltz, each in its own lane, its own orbit. Venus is the second dancer from the center. It follows a path that is closer to the sun than ours. On average, Venus orbits the sun at a distance of about 108 million kilometers, or about 67 million miles. A year on Venus is only about 225 Earth days long. Venus is our closest planetary neighbor. At its closest approach, when both planets are aligned on the same side of the sun, Venus can come within a mere 38 million kilometers or about 24 million miles. This proximity is why Venus appears so bright in our sky, shining more brilliantly than any other object in the night sky except for our own moon. This cosmic dance has some strange choreography. Venus spins on its axis incredibly slowly. In fact, it spins backward compared to most other planets, including Earth. While Earth completes a spin in 24 hours, it takes Venus 243 Earth days to rotate just once. A day on Venus is longer than its year. Being closer to the sun means Venus receives almost twice as much solar energy as Earth does. This constant, intense bath of sunlight is the first ingredient in the recipe for the planetary inferno we see today. Let's descend through the clouds. What does Venus look like up close? The planet is wrapped in a thick, uniform blanket of pale, yellowish-white clouds. These aren't fluffy water vapor clouds like on Earth. These are clouds of sulfuric acid, corrosive enough to burn skin and metal. They are a permanent global shroud hiding the true nature of the world below. The reality is much harsher. Venus is the hottest planet in our solar system, even hotter than Mercury, closer to the sun. The average surface temperature is a staggering 465 degrees Celsius, or about 870 degrees Fahrenheit. That's hot enough to melt lead. And this isn't just the temperature at the equator during the day. It's the temperature everywhere on the planet, at the poles, on the night side, all the time. There is no relief. The relentless heat is maintained by a phenomenon called a runaway greenhouse effect. The thick atmosphere, rich in carbon dioxide, traps heat, preventing it from escaping. This process spiraled out of control billions of years ago. Could you breathe the air on Venus? Absolutely not. There is virtually no free oxygen in the Venusian air. The atmosphere of Venus is an alien cocktail of gases, completely different from the nitrogen-oxygen mix that sustains us. It's a thick, heavy, and toxic soup. About 96.5% of the Venusian atmosphere is CO2. On Earth, carbon dioxide is a trace gas. But on Venus, it is the main event, the runaway greenhouse culprit. The atmospheric pressure at the surface of Venus is about 92 times greater than what we experience on Earth. Standing on Venus would feel like being nearly a kilometer deep in one of Earth's oceans. The weight of the air above you would be immense, a physical force that would crush most human-made machines, let alone a human body. This thick atmosphere creates strange weather. At the cloud tops, winds whip around at speeds of up to 360 kilometers per hour, much faster than the planet itself rotates. However, down at the surface, the air is thick and stagnant. How did this terrifying world come to be? The story begins about 4.6 billion years ago, with a vast, cold, spinning cloud of gas and dust, a solar nebula. At the center, gravity pulled matter together until it ignited to form our sun. The leftover material, dust, rock, ice, flattened into a rotating disk, the cosmic nursery where planets were born. Within this chaotic disk, tiny dust grains began to stick together, growing into pebbles, then rocks, then larger bodies called planetesimals through accretion. Venus and Earth, forming in neighboring zones, were built from very similar raw materials. In its early days, Venus might have been very different, a cooler world with vast oceans of liquid water. The young sun was fainter then, so Venus might have been in the habitable zone. Imagine a second blue planet, a true twin to Earth, with the potential for life. It's a tantalizing, almost tragic thought, but as the sun grew brighter, more water evaporated. Water vapor is a potent greenhouse gas, creating a feedback loop that eventually spiraled into the runaway greenhouse effect we see today. What lies beneath that permanent toxic cloud cover? For centuries, this was a complete mystery. We couldn't see through the clouds, but radar revealed the truth. What we've discovered, a world shaped by volcanism on a planetary scale. The surface is a vast, rolling volcanic plain, punctuated by thousands upon thousands of volcanoes. The ground is mainly basaltic rock, dark volcanic rock common on Earth. When Soviet Venera landers touched down, their data confirmed volcanic rocks and soils. Think of Hawaii or Iceland. Now scale those landscapes up to an entire planet, then bake them under an oppressive, crushing, superheated atmosphere. Venus lacks plate tectonics like Earth, instead it releases heat via massive, planet-wide eruptions. The surface is geologically young, only 300 to 600 million years old, implying catastrophic global resurfacing. The landscape features two continent-like highlands, Ishtar Terra in the north, hosting Maxwell Montes higher than Everest, and Aphrodite Terra straddling the equator, larger than South America. How do we know any of this? We know it because we've gone there. Not with people, but with our robotic emissaries, our eyes and hands in the cosmos. The intense heat and crushing pressure make Venus one of the most difficult places in the solar system to explore. Early spacecraft were crushed, melted, and fried within minutes. The Soviet Union made Venus a primary target with the groundbreaking Venera program. In 1970, Venera 7 became the first spacecraft to land on another planet and transmit data back to Earth. Later missions did even better. Venera 9 and 10 sent first black and white images. Venera 13 and 14 sent first color pictures showing orange-brown rocks under a dim orange sky. The United States contributed majorly with radar mapping. NASA's Magellan was the crowning achievement, arriving in 1990 to map 98% of the planet's surface in stunning detail. Today the journey continues. Japan's Akatsuki studies extreme weather, new missions are on the horizon, NASA's Veritas and Da Vinci, ESA's Envision, adding pieces to the puzzle of Earth's lost twin.